All right, Geometry Rock Stars, welcome.
We are on Unit 7, Lesson number 6. We're talking about interior angles formed by chords and secants. So last lesson, in Lesson 5, we talked about what a tangent line is and what a secant is. And what we're going to do is talk some more about those things and the angles formed by chords and secants and all sorts of fun stuff. So here we go. Let's take a trip down memory lane. The exterior angle of a triangle is equal to the sum of the remote interior angles. That's our triangle exterior angle theorem. That means in our first diagram over here, if I wanted to solve for x, what I could do is take the two remote interior angles. That means the two angles that are remote far away from the exterior angle. These two angles, 2x minus 6 plus the 40, will add up to equal the 80. So that's how we can make an equation. From there, we can solve for x simply by combining like terms, subtracting 34 from both sides, and then dividing by 2, and we get x is 23. So that is the exterior angle of a triangle theorem. Triangle exterior angle theorem. The two remote interior angles add up to equal the exterior angle. So our exterior angle is found by adding up the other two remote interior angles. Rule number 2 we are remembering is that an inscribed angle is equal to half the intercepted arc. So our value of x is equal to half of 120, so x is 60. We are going to put those two things together and come up with dun, dun, something new. So here we have we have a diagram. We do not know where the center of the circle is, but we have chord AD, we have chord BC, we have arc A marked and arc B marked with angle X. What we are going to do is try to figure out a formula of how to find angle X. And to do that, we're going to start with an auxiliary segment AC. So what I want you to do is connect AC on your paper and draw in that triangle, triangle ACG. Now, angle AGB, where X is located, is an exterior angle to the triangle that we just drew. So if the triangle ACG has an exterior angle of X, then by our exterior angle of a triangle theorem, by the exterior angle of our triangle theorem that we had up here, then the measure of X is equal to angle GAC plus angle GCA. Now, the next thing we need to look at is the fact that those angles are inscribed angles. So if those angles are inscribed angles, then angle ACG, being an inscribed angle, is half of arc A. So angle ACG here is 1/2 of A. And similarly, angle DAC over here would be half of arc B. The inscribed angle is half of the intercepted arc. So if angle A over here is half of B, and then angle C is half of A, that means our angle measure X, the exterior angle of the triangle, is equal to the sum of those. So X is equal to half of A plus half of B, because it is the exterior angle, so it's equal to the sum of the two remote interior angles. Factor out the 1/2, and we have our formula. The measure of an angle formed by two chords is half the sum of the intercepted arcs, which means it's the average. If you add two things and divide by 2, you're taking its average. So you're taking the average of the arcs. Now let's be clear which arcs we are referring to. The first arc that we used was AB, which was that angle. And then the second arc that we used over here was arc CB, which was double. You took it half of that to get the other angle. So our two chords, if I redraw these to cover up all the colors that I've used, our two chords intersected to form angle X, and the arcs that are used to find that angle, you do half the sum of the arcs. The arcs that are used to find that angle are the intercepted arcs inside the angle. So there's our two arcs. And the angle X is half the sum of those two intercepted arcs. So interior angles formed by two chords, or you could have secants if they were drawn longer, equal half the sum of the intercepted arcs. So now what we get to do is apply it and try it and do it and use it. So find X and Y. The angle X is equal to 1/2 the sum of the intercepted arcs. Our intercepted arcs here are highlighted a little darker. So it's 1/2 the sum of 150 plus 80. So you add the two angle arc measures, add the two arc measures together, divide by 2, and you have your angle measure. To find Y, we can just use linear pairs. So subtract from 180, bada boom, bada bing. There you go. Number 2, similar types of calculations. What we need to do here, let me get to my pens so we can highlight some stuff. So our inscribed angle here, DEG, is 41 degrees. That is half the intercepted arc. So I'm going to take this angle and double it to get arc CD to be 82 degrees. So that is the first thing that we do. Now that I know that arc, I am then going to use similar strategies with angle EDC to get arc EC, because that inscribed angle of 78 degrees can then be doubled, and then get arc EC as 156 degrees. So that's what I'm going to do second. Next, because my circle is perfectly round, which is why I called it a circle, I know that BC is a diameter, which means arc BC is a semicircle. So if I know that EC is 156, then I can easily solve for X by subtracting from 180. So I get X is 24. Now that I know arc X is 24 degrees, and we know arc CD is 82, so I know arc X is 24 degrees. We know CD over here is 82. I can go back to my original diagram, use the rule where when two chords intersect, the angle measure is half the sum of the arcs. My arcs here would be 82 and 24. So use the formula, find your answer. And there you go. So now you are just off and running, practicing on your own. Use the answer keys as you need. That's it for me. These diagrams can get tricky, so the answer key is going to be helpful. But do your best, and we'll talk soon. And good luck.